All right, here we go. Sketching the graph of a factored polynomial. So now look, in example number 6, what they've done is they've already factored the polynomial. So I've got x squared plus 2, or x plus 2 cubed actually, I apologize, times the quantity x minus 1 squared. And we're asked to graph this. Now here's the thing, how many x's are there? Well, this will be multiplied by itself 3 times, so I've got 3 x's coming from this. This will be multiplied by itself twice. So this is a 5th degree polynomial, right? Do you guys see that, where that's coming from? Now if I'm going to write this out, and you won't have to do this in your homework, I'm just doing this to kind of illustrate so that you can see what this is really saying. What it's saying is our polynomial factored out is x plus 2 times x plus 2 times x plus 2 3 times x minus 1 times x minus 1 twice. Okay? And then if I were to multiply that all the way out, I get something x to the 5th power, then something x to the 4th, x to the 3rd. So I get this really long polynomial, and I don't need to multiply it out because I have all the information I need to graph. So what is this saying? Well, a 5th degree polynomial, because we got to graph it basically. And we have a calculator, but we're going to cheat a little bit. So what are we doing? Well, we're saying that x equals negative 2 and x equals positive 1 are 2 solutions. Because if I take this, set it equal to 0, x equals negative 2. If I take this and set it equal to 0 and I solve, x equals positive 1. Do you guys agree with that? Do you guys see that? Do I need to write it down, or do you understand what I'm saying? Okay. So that means that at negative 2, so if I come over here at negative 2, I'm going to have an x-intercept there, and I'm going to have an x-intercept here at 1. Now because it's an odd degree polynomial, that means that this graph is going to come in down here and go out the top. The interesting thing though is that it has some multiplicities, and so what would that look like? It's not going to cross more than once or twice, right? It's going to cross here and it's going to cross here. It comes in here, crosses here, and goes out there. So what does that mean? What does that look like? Is it going to come up here? It can't cross a second time. Once it crosses here, then what does it do? Or does it even cross? In fact, we don't even know if it has to cross at least once, but the multiplicity thing throws us off because it could have 4 or 5 solutions, but we really only have 2. But this is a multiplicity of 3, and this is a multiplicity of 2. So we have a multiplicity of an even multiplicity and an odd multiplicity. So what does that look like graphically? Well, if we graph this in our calculator, it's going to come up this way, and it's going to go up this way, and it's going to come back down, and it's going to go up this way. That's the behavior of the function. That's what it looks like if you graph it. And in fact, let's graph it on the graphing calculator. And I don't need to expand it out or anything. I could just graph it the way that it's written in the textbook. I could say x plus 2 raised to the 3rd power times the quantity x minus 1 raised to the 2nd power, and graph it. And that's exactly what it looks like. I mean, I'm zoomed. I've got like a funny zoom going on here, but okay. One thing I want to point out, for an even multiplicity, you get this thing where it just touches the x-axis but never really crosses. And for an odd multiplicity, it goes through the axis. Did you guys know that? Now you do. Okay. That's all I wanted you to know.